Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote. So here we go with the quote of the lesson. You become what you think about. Now, those are powerful words from Napoleon Hill. The focus of this lesson is the present value of an ordinary annuity. An even annuity, as you may remember, is made up of frequent payments that are level or even in terms of amount and timing. Now on this slide, notice how the OA for ordinary annuity is in parentheses. Why? Because we can calculate the present value of an ordinary annuity using the PV key on your financial calculator. This notation relates to the third window of the TVM wallet, as we'll see when we walk through the real-world example for this lesson. As far as timing is concerned, the present value of an ordinary annuity is as of one period before the first payment in the series. In a prior lesson, we've discussed how all but the building block true investment yield equation really come down to PV or FV, and how you can use the PV and FV keys on your financial calculator to solve for not only the present value or future value for a lump sum payment, but also for an annuity or perpetuity. In other words, the present value of an ordinary annuity, the present value of an ordinary perpetuity. Forget about et cetera, we're on a roll. The future value of an ordinary annuity, the future value of an annuity due. And last but not least, the present value of an annuity due and the present value of a perpetuity due. You might be wondering, why do the present value of an annuity due and the present value of a perpetuity due have an asterisk? Well, it's because, as we'll see in a later lesson, we use the FV key to solve for these values. Why? Because I do not teach begin mode. Why don't I advocate using begin mode? I've talked about this in a prior lesson. I've got a future lesson teed up and ready to go exclusively on this topic. But if you want to read more about my thoughts on begin mode and you just can't wait until we get to that future lesson, feel free to visit our blog at boxhomepress.com. Here's the real-world situation we'll be analyzing in this lesson. Can you tell that I don't want summer to come to an end? So here's the quick summary. You've got a person in this example. Let's put ourselves in this person's shoes. It'd be great, wouldn't it? And they want to get out of Dodge a year from now. It's the beginning of the year. Call it January 1st. They've got their New Year's resolutions. They want to get not only physically fit, but they've got a whole list of things they want to do. And oh, by the way, they're financially fit right now. This person has $800,000 in an investment account, and we're trying to figure out, is that enough money to fully fund this amazing adventure that they want to take that's going to take them around the world over the next 15 years? Wouldn't that be nice? So we need to solve for the present value of an ordinary annuity. So the first thing that we're going to do here is draw our TVM wallet. But notice how I said we're going to solve for the present value of an ordinary annuity. Now, the language in this question might throw some people off because in this example, it's January 1st or some date close to January 1st. And at the beginning, so come a year from now, this person wants to start taking annual withdrawals. And this is going to be a $96,000 withdrawal that happens at the beginning of the year. That's the language. The word beginning can throw some people off. But as we'll see, we don't use the building block present value of an annuity due equation to support this math. It's easy to use the building block present value of an ordinary annuity equation to double check our work, like we'll be doing on the next slide, but that is the equation that is going to help us here. So the first thing that we need to do is draw our TVM wallet. Look, I drew a little bit over myself there in the circle, but that's okay. Here's the TVM wallet, and we're going to write out the 5 primary time value of money variables. These are the ones that we're going to use more often than not when working out a situation. We've got our timeline so that we can visualize. I don't know about you, but I might be visualizing later tonight when I go home. I'm going to be visualizing this kind of adventure, because wouldn't this be nice? And this calls for annual withdrawals of $96,000. So how are we telling time for this time span in between period markers? Well, it's an annual time span. These are annual withdrawals that are contemplated. So in the subscript for uppercase N, we're going to write A to remind us how we're telling time. We've talked about the relationship between PMT payment and uppercase N. So there are 15 of those $96,000 withdrawals or payments. 0 is the value for future value. Why? Because there's no lump sum value in the future. We've got an annuity that we're trying to value here, and we're trying to value that in the present. And so this is what we're solving for, the present value of an ordinary annuity. So we're going to circle that. We can put OA in parentheses. That's kind of slick, isn't it, to remind us what we're dealing with here. But we need to solve first for the true annual investment yield. Why? Because we've got an annual time span in between period markers, so only a true annual investment yield will work. Remember, we have an annuity here. This is a $96,000 annuity that is contemplated. So, and that's an annual withdrawal at the beginning of every year, and that first payment will occur 1 year from now. So we're being told how to tell time. Remember, as we go through the 3-1-2 warm-up routine, first we count money. We're dealing with an annuity. It's $96,000. It's an annual annuity. Then we move on to how we tell time. Well, it's an annual annuity, so it's an annual time span between period markers. And last but not least, we read and write I. And so that's what we're going to do right now. We're going to solve for the true annual investment yield. So I'm going to write the building block true investment yield equation. This is what we're going to be using to solve for I, because that's the butterfly rate. That's the only rate that will fly. We were told that this person's investment portfolio is largely invested in bonds that are paying interest semi-annually, and that simple semi-annual investment yield, you could think about it like an interest rate, but I like to say investment yield because that's kind of the catch-all term, is 4%. So 0.04, that's 4% in the decimal form. And because these bonds in this person's investment portfolio are paying interest semi-annually, we can put a 1 value for lowercase c. So we can assume a semi-annual compounding period. So let's take it from the top. The 4%, or 0.04, which is 4% in the decimal form, that's what I call the caterpillar rate. But let's put more words to that. It's a simple semi-annual. If I said annual earlier, I misspoke, I'm sorry. A simple semi-annual investment yield. When we divide by 1, what are we left with? Well, we're left with the chrysalis rate. Kind of looks like a chrysalis, doesn't it? But let's put more words to it. It's still a simple semi-annual investment yield. So let's add 1, put the square brackets around this. And the next thing that we need to do is figure out the right question to ask. So how do we take a simple semi-annual investment yield and turn it into a true annual investment yield? Again, why would we want to do that? Well, because we're being told how to tell time. This situation contemplates an annual withdrawal, and so an annuity that's going to happen every year. And so we need to make this jump. We got to ask ourselves the right question. And the right question in this example is, how many semi-annual periods are in a year? And the answer is 2. And so that's the value for lowercase n. And when we work out this math, we get 8.16%, which is our true annual investment yield. So that rate is going to fly. That's what we call the butterfly rate. Now in my trusty HP12C, I need to input the percentage format. Your calculator may be different, but that's the way it works for me. And when we solve for the present value of an ordinary annuity, and remember, the TVM wallet is meant to be used in conjunction with your financial calculator. So hopefully you're following along at home or wherever you are. And when we solve for the present value of an ordinary annuity, we get negative $813,742.74. So this person's just a little short. Remember, the question was, how much more is this person going to need to save so that the investment portfolio will fully fund this 15-year adventure around the world? Wouldn't that be nice? And the answer is, well, this person's going to have to figure out how to come up with $13,742.74, and hopefully they can do that. And I'm sure they'll be able to do that. So let's move on to the next slide where we double check our work. And no surprise, we're going to be using the building block present value of an ordinary annuity equation. Again, some people might be thrown off by that at the beginning of the year is when the first withdrawal is going to happen language, but we don't want to be that person. And so the present value of an ordinary annuity equals PMT payment times all of this in the square bracket. 1 plus I, that's the true investment yield, raised to the power of n, and that's uppercase N. 1 plus I, again, raised to the power of n, uppercase N, times I, the true investment yield. So the present value of an ordinary annuity equals $96,000. We know that payment, the PMT payment. We also know the true annual investment yield of 8.16%. So we have to write that in here in the decimal form. There are 15 of those $96,000 payments. Again, we've talked about the relationship between PMT payment and uppercase N when dealing with an annuity. And we see that here again. 1.0816 raised to the power of 15 times the true investment yield. Here, the true annual investment yield, 0.0816. And when we work it out, we get a value of $813,742.74. And that's great because that's the answer that we found in our TVM wallet. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Practicing finance takes practicing finance, including having a working knowledge of the building block time value of money equations. In the book, Would Your Boomerang Return, you'll find the first of its kind user manual for the mathematics of finance in the How section, followed by some of what I learned from practicing in the field of finance for 22 years in the Why section of the book. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.